Okay, welcome to a third and final example on relative velocity that I'm going to post for you. This one is one that I haven't written down for you before, but it is a very standard, and we will have done one similar to it in class. This is just a supplementary, just an extra example if you need a little further explanation. In this example, you might want to write it down, and if you do, you can go ahead and pause. But in this example, you've got Eddie who's swimming. He can swim in still water, 3.5 meters per second. But today the water's not still. Today the water's traveling perpendicular to his motion at 3 meters per second east. He is aiming to cross a 40-meter wide river. So the three things we want to know, and this is very typical for a question like this, the three things we want to know are how long is it going to take him to cross, how far downstream will he land, and finally, if he did want to end up straight across, so sort of a different situation in part C. In part C, it's a whole different question. In part C, it's saying he's no longer aiming straight across. He's now aiming upstream so that he gets carried directly across from where he started. So where should he aim? So where would imply an angle? Okay? So in the three questions, we're looking for time here, some D here. We don't know which D yet. And where will mean some angle. Where should he aim? So on the next, if you need to pause to go ahead and write the rest of the example, you can. But I'm going to move ahead to the next page and we'll start solving the question, solving the problem. Okay, so in a question like this, the clear place to start is by drawing a picture. So if I was going to draw this river, we're told that the water is flowing at 3 meters per second east. So let's do this. North and east, positive. And we know the width of our river is 40 meters across. And so the information that we're given, and using the proper terms as far as the variables, we're given the water speed, the river speed. We call that water with respect to shore. And it's 3 meters per second east. We're given how fast Eddie can swim in still water, and that would be the swimmer with respect to water. So swimmer, and that's water. And this one's water with respect to shore. And his speed is 3.5 meters per second. And for part A, we're assuming that he's traveling due north. He's trying to go straight across the river. And the last thing, we're given that's actually all we're given. Okay, so if we drew a little picture here for part A and B, that's relevant for part A and B. We'll look at C later. Here's a case where he aims straight across. That's really what we're going to call swimmer water. But the water takes him this way, so that's the water shore. So his end result ends up being this. This would really be the swimmer shore, right? And the swimmer shore and the side. So when it asks us in part A, how long does it take him to cross? This one always gets people a bit confused, but it really is as simple as saying, in this north direction, if you want to call that the Y direction, whatever, in this direction, we have a speed, and that's his speed relative to the water, okay? We also have a distance, and the distance is 40 meters. So in the, if you want to call it Y direction, or north direction, the velocity is going to be 3.5, and the distance is 40 meters. Therefore, his time is distance divided by speed, and it takes him 11.4 seconds to cross. So even though he ends up going this far, in the direction that he's swimming, in the direction that he's crossing, where he has to cross 40 meters, in that direction, he can swim at 3.5 meters per second. So it ends up taking him 11.4 seconds to cross. Now, the question of how far he gets carried downstream then is actually just a matter of saying, in the direction of the downstream direction, he's moving at 3 meters per second. So for part B, this is part A. In part B, in the downstream direction, or X direction, his velocity is it's not any of his velocity, it's entirely the velocity of the water carrying him downstream. So the velocity is going to be the 3 meters per second, and the time is going to be how long it takes him to cross, which is 11.4 seconds. So therefore, in that direction, he's going to move, so therefore D equals VT, and it ends up being 34.3 meters. So the trick to solving these river questions is to not worry too much about the angle, at least in this part. We don't really care that much about what happens in this direction. We want to know how long it takes him to cross that distance, and we know the speed and that he's traveling that way, and we want to know how far he's going to come this way, and we know the speed the water is going to carry him. Okay, so that's part A and part B. Part C is a bit of a different story. It's actually even easier than part A and B, but you just have to see it first. So making sure you understand what the question is. In this one, we want his end result to be straight across. That's where we want him to end up. And that really is what will be at swimmer shore. But we're not going to worry too much about that. What we do know is that to get there, he's going to aim this way, and this would be swimmer water. That's 3.5 meters per second. And he's going to get carried by the water this way. And the question it's asking us is, where should he aim? So to start with, we could find this right angle triangle. If I found this angle right here, then I could, maybe if I want to report the angle as north of west or something like that, maybe I want to report it in terms of this angle. But I can find this one using trigonometry, because sine of theta equals opposite over hypotenuse. Therefore, theta is 60 degrees. So, Eddie must aim, I'm going to say 30 degrees north of west. End up straight across. So when you're looking at a straight across question, again, you don't need to worry much about his velocity with respect to the shore, which is what this is here. You don't have to worry about that too much. You know where he's aiming, and you know where he's going to be carried. Just worry about that. Okay, so that's a typical river question.